Oh yeah, definitely. You can definitely get help with the even ones once we go through the odds. So number 1, notice it does not want you to factor the whole thing because it's not even factorable if you tried. So it says, what is the greatest common factor of this? Just meaning, what can we divide everything by? You know how usually in the beginning we look at it and I say, oh yeah, you can divide. You can definitely divide by, always try the smallest number first. If it works, then you don't have to worry about anything else. The smallest number is 5. Yes, you can divide everything by 5. So that means the GCF is 5. So let me just give you a hint for number 2, because it says after factoring out the GCF from number 1 right here, what is the resulting polynomial? Which means basically after you divide by 5, what's left over, that will be your answer for number 2. Okay? So number 3, before you start doing number 2, pay attention, we got to get through number 3. So number 3 says identify the GCF of 40x minus 24. So once again, we're trying to figure out what can we divide both of these by in the beginning. So one of the ways we first started off doing this was we would put the product inside. That's a hint for some other questions. The product goes inside of the box, and then we bring our GCF to the front. We try to figure out what number to bring to the front. So if you haven't kind of got the hint about that one, then yes, you're going to have to do put 40x here and then negative 24 and try to figure out all the factors so we can find the greatest common factor. If you haven't really been catching on to the hints that I have, maybe you've been asleep like some people I see and you haven't caught the hints. So 1 times 40 is 40, 2 times 20, not a 3, but a 4 times 10. Remember, you can get all of these from your calculator. I just want to remind people about how to find all those factors. Put the number in there, 40, not the x, just 40 divided by x, and it will give you all of them. Remember, I'm doing this for video purposes for people that are at home and they want all of the steps because they are studying, okay? So if I'm moving too slow, just write your answers and move on. That's for the people that are currently in class right now. Okay, so 1 and 24, or 2 times 12. Remember, no decimals, because yesterday people were still writing decimals. So 3 times 8, 4 times 6, and then we're looking for the biggest number. Sure, I think they both have a 2, but that's not the biggest one that they have in common. Yes, 8. I'm not really caring about the negatives too much because they both don't have a negative. If they both had negatives, sure, I would bring that out to the front. But I'm looking for an 8. Do I have to bring the x to the front?
No.
No, because they both do not have x's. So the GCF for this one is 8. And then same thing here. What is the remaining polynomial? That's asking what would go on top. That would be your answer. Well, maybe I shouldn't put a box because then it looks like I'm setting up another box. But your answer would go here. Sorry, I was not making a box telling you to do box method. I was just showing you where to write your answer. Any questions before we move on to number 5? Nope. So whatever goes on top will go here. Like I said, let's get through the odds first, then you can go back and do the evens. Number 5, it says which expression is equivalent to 12x squared minus 42x. Notice it is missing the c, so we're not going through all of those steps for the a, b, and c. We kind of just have a half a box here. Then we are bringing our GCF to the front. One thing that can help you is if you notice this has an x squared and so, well, this has an x. That means you definitely have to have what in front? Something with an x. We're not really sure what number, but we know that number has to have an x. So you can eliminate something right now. Because whatever I bring to the front has to have an x with it, which means it can't be c or d. So that means either we're going to bring a 2 to the front or we're going to bring the 6 to the front. So you can try bringing a 2 right here, see if it works out. But this is a minus or a negative 42. So then in that case, if you need to, you can work backwards. If I put my 2x and then a 6x plus 21 here, what would that product be for those factors? That would be 12x, and then, oh, everything's positive. That would make, I'm sorry, that should be a square. Everything's positive, so that would make that a positive 42. So is it A?
No.
Nope, must be B. So the reason why it is B is because I got a 6x, then 2x minus 7. We needed that negative 7. Ooh, I'm about to mess up my pen. All right, 2 times 6 is 12, x squared. Sorry, I'm writing so small. And then 6 times negative 7. That's where the negative 42x comes from. So yes, it is B.
At any point, will we use decimals for trinomials?
No, we will not. When you're factoring, you are not looking. No decimals will be. Nope.
At any point,
not that I can. Not that I can think of. Nope. All right. So 6 and 7. Remember, you're doing the evens. I'm helping you with the odds here. So it says, what is the area? The area is the same thing as the product, which is found on the inside. So we're counting up. Yes, we're counting up the tiles on the inside. When you go back and do the factors, you're going to have to do the cut the pizza backwards thing. Remember we talked about cut the pizza backwards? But right now, area is already given to you. So remember, the big ones, what are these called?
X squared.
How many of them do we have?
2.
So there's 2 for the x squareds.
And then there's 3.
Now there's 1, 2, 3, 4 with an extra, that's like a negative one. Remember what happens with the negative and the positive? This one and this one cancel each other out. So there's really only 3. 3 what? Those are the x's.
And then minus 2.
Then these 2 down here, thank you. It's just, there's just 2 of those little negative tiles. Number 8, you're going to do that one yourself. Remember what the dimensions are? Dimensions are the factors, so they're telling you the factors that go on the outside. Number 9, Vanessa used a box to help her factor a trinomial. However, she's having trouble completing the box because she was asleep during class the day before. No, sorry, it doesn't say that. Help her complete it. Okay, so, it doesn't give us everything, but we should be happy that this has a invisible 1 coefficient, because the only thing that could go here is what? X times x is x squared. And good, I'm looking for 2 things I do have so I can get that, because I am multiplying these. Yes, 6 times x is 6x. But when you're missing something, either you can kind of think what will go here or divide. Take what's in here, divide it by this. These numbers are small.
So that makes it a negative 2x.
And then you can multiply these 2 since we have these on the outside. It gives you a negative 2x. So we helped her complete that. And then, remember dimension, what's another name for dimensions?
Outside, the factors.
Factors, outside. So when you do that, you should have 2 factors. Area, however, is the inside.
Oh, that's easy.
It should be easy, hopefully. We've been doing this for like the past month here, people.
4x.
We got 1x squared.
12.
These 2 need to get added together because they're like terms. Don't forget about combining like terms.
4x.
Looks like more people are falling asleep. I know, yes, you should know how to do this already. But hey, we all need reminders sometimes. Even yesterday, I was working with Mr. Freestone, and he was doing that long division problem. And I was like, whew, I forgot how to do that. And then he showed me. I was like, okay. But I was like, I don't remember because I haven't done that probably about 5, 6 years. So Remember how we always forget things the next day? So please, don't think because you got it yesterday, you remember today. Wake up. And then 13, product. Same thing, inside. The product is inside. The area. All of those mean the same thing. I'm not offended. No, not the factors are on the outside. So that one, you're doing that one by yourself. So write it down. Don't tell nobody. That's like a secret. The inside, once again, 5x squared will stay. These two, we add them together. 10 plus 9, 19, and then the 18 will just stay there. That's our answer for that one. That should be the easy stuff. I mean, most of it should be easy besides just making sure we take our time to factor. Number 14, a lot of people keep getting that one wrong. I don't really know why, but we'll go back to it at the end because that's an even. We're looking at the odds. Which of the following would create a perfect square? PST. P stands for perfect. And we know it's perfect because both factors are the same. Exactly the same. All right? These two are not the same. That's a difference of two squares. Because the numbers are like, oh, that's 16 with a minus 25, 16 with a plus 25. That's a difference of two squares. Okay. If you're looking at B, well, if you look at this one, it's missing a B. And remember, one of the characteristics of difference of two squares is if it's missing a B. But that's not what they're asking. They're asking for a perfect square trinomial. It definitely is C. And you need to remember that when they put the power of 2, that just means somebody got lazy. And there's two of the same exact things. Because, yes, math people get lazy too. So we just put a power of 2. Yep. Why do you think there's invisible ones and then nobody writes the zeros? Power of 2, because math people were getting too lazy. Number 17. Number 17 is a factoring problem. No, you can't divide by anything. So A, B, C. A is 49. B is 0. C is negative 9. We're going to be factoring for a long time, people. Don't think just because we're taking a test on Friday, factoring's over. We're factoring again for that next test because we're actually going to be adding a step to this factoring.
Wait, what?
So people, yes, people like you will be very happy because it's not just the same old boring factoring. We're adding another step to it. So like this is why we've been practicing this for a long time because the next step, super easy, bam, then we'll be doing what we need to do then. So 49 and negative 9.
That's 58.
You get negative 441 if I remember from the last class. 49 times. Remember, we're multiplying A times C. It's in the 20s somewhere. The answer is in the 20s somewhere because we're looking for it to add up to 0. So it has to be a 0 pair. Thank you. Somebody found it. 21 and negative 21. That's what we need. 21C. The only reason why I knew is because it has to be a 0 pair. And somebody in the other class found it. Thank you. One of those has to be a negative. That's the only way to add up to a 0. Then use your answer choices to help you. We should not have to be searching too far along trying to figure out what's going to help us here.
The back is going to be a 3.
Yes, has to be that 3, negative 3 to get this one. Yeah. That's the only one that will work out. Because, honestly, it's because 7 times 7 is 49, and 3 times negative 3 gives you a 9. That's why it's called a difference of two squares. It's because this is a square root, this is a square root, it's a perfect square number, which doesn't help because then you get confused with perfect square trinomials. So just be careful on this one. If you need to ask me when you get here, I don't mind helping you out, telling you where you should look. And then number 19 and 22, sorry, 19 through 24, we're just factoring, which should hopefully be getting easier. The more we do, the easier it gets, hopefully. All right, so I'm going to set up the steps. A is 1, B is 10, C is 16. No, there's nothing to divide by because we have the number 1 for our A. If any of them are 1, we don't need to divide. And we know we can put our first term here, last term here. This one's going to be super easy because there's no coefficient. Don't sleep now and ask for help later. Come on now. Guess you'll be watching the YouTube video. And
perfect square, is it?
This one's not a perfect square. No.
Wait, no, it's not. I don't know why I'm thinking of 81.
Oh yeah, what'd you get?
64.
1, 16, 2, and 8. Thank you. I heard somebody say it. 2 and 8. 2 and 8. 2 plus 8. Give me the 10. So y, positive 8, positive 2. Yes, everything's positive. You don't have to worry about anything not being positive. Those are our factors. With 21, we're going to do the same thing. No, there's nothing to divide by, because if I try a 2, 9 divided by 2 ain't going to help us. So A is 9, B is negative 2, C is negative 7. I'm going to use this side over here because I don't have much room there. 9x squared minus 7. So I got to multiply these two. I get negative 63. So I'm going to write down all my factors for 63. I mean, you can use a calculator. I'll show you a calculator on this one. Oh, battery miss. Oh, there we go. So negative 63 divided by x. Just in case you might be watching this for the first time and you don't know where I'm getting these numbers from. So I'm only looking at whole numbers. So I got 1, negative 63, 3, negative 21, 7, negative 9. What I usually tell people is just write down the first couple of sets of factors and then go back and say, hey, does 1 plus negative 63 add, oh, I'm sorry, no, I must not. 1 plus negative 63, does that add up to the B? That's why the B is special. Nope. 3 plus negative 21. Does this one add up to the B? Nope. 7 plus negative 9. Does it? Ah, now we found it. We found our special pair that need to be included in our box. That's the only pair that's going to work. I'll show that again on the next one just in case you're watching at home. So now I'm going to finish up this box by bringing the GCF to the front. And I'm happy because both of these are 9s. That means I have to bring a 9 out to the front. When they're both the same number, you bring that number to the front. So the only thing that could go here is 9 times 1. X times x is x squared. Negative 1 has to go here in order to produce a negative 9 when I multiply 9 times negative 1. Then a positive 7. So it's an x minus 1. You see how this one put x plus 1? They're trying to trick us. Nope, it has to be this one. So now I'm going to do number 23. I'll show all the steps again, just in case you're watching at home. But for 23, there is something that needs to get pulled out in the front. I'm sorry, GCF needs to get divided out, which means my factors will end up having a 2 in the front of them. So that divides into 1x squared plus 5x plus 6. The A, B, and C is definitely quite obvious for people these days, so we should not have to keep writing that. A is 1, B is 5, C is 6. So the next rule is to multiply the coefficient 1 times 6. Then I'm going to get 6. So now I put 6 divided by x on my calculator. I'm just going to write down the first couple of factors. 1 and 6, 2 and 3, 3 and 2. They just flipped it on me, so it's the same thing. You don't have to rewrite it unless one's now, the negative is on a different one. But there's nothing negative. So is 1 plus 6, does that equal 5? No, so I'm not using that pair. Does 2 plus 3 equal 5? Yes, that's why I'm going to choose that pair, or else the box won't work. And then, oh, I'm happy because I just have a plain x squared. The only thing that could go here is x times x. And then this has to be a 2, because 2 times x is 2x. And then 3 times x is 3x. So one of the factors, x plus 2, the other one is x plus 3. And those are the odds only.